I'm Jonathan. I wasn't on the list before, so I'm kind of your surprise speaker for today. And I'm going to talk about cross-thread stack traces. So let's start with like a quick example of the problem. So let's say that we have this function here, and it takes a string as a parameter. It starts a future, and then it sums the ASCII codes of the characters in the string. And if they're even, it's fine. Otherwise, it'll throw an exception. And here we have two calls to this function with hello and banana. And we don't know what's going to happen because we don't see the main function, right? So let's see what happens when I run this. OK, so we get an exception. It says error. And we get this line that brings us to here. And that's all we can see from the stack trace. But does that really help us? I mean, to know that we ended up here. So obviously, there was an error, but we don't know how we got here, which of these functions were called. Were they even called at all? We don't know, right? So let's think about this a little bit. So this is what happens, right? So we have this function. And basically what happens is that we have two thread contexts, right? There's one before the future, and there's one inside the future. So before the future, the function was called from the main function and so on. And in the future, this is where we threw the exception. And stack traces are specific to a single thread. So what we get is the stack trace that belongs to this part of the code, right? It's disconnected from this part of the code. And wouldn't it be cool if we could get the stack trace from this part as well and somehow combine them? So we could see like a full trace of how we ended up in the exception state. So stack traces actually come, well, they get populated by the constructor of throwable, which is the base class of exception in the JVM. So you can actually see the code if you look into it, and it says fill in stack trace right in the constructor. So whenever you throw a new exception, this is where you get the stack trace, right? So at this point, it's kind of already too late, right? Because we've already switched into the other thread, and we've lost the context of the original thread that we came from. So maybe what we should do is, press escape, get the stack trace here before we enter the function, the future, sorry, and hold on to it in case there was an exception. So let's see how to do that. That's actually pretty simple. So this is the same thing that you saw before, the same future. But before we enter the future, we will just get a copy of the stack trace for the current thread, okay, before the future. And if the future fails, we'll just grab the exception. We can edit the stack trace, it's mutable, and concatenate the trace from the previous thread right at the end. And we can even put a nice little separator in between them. So let's run this now and see what we get this time. Okay, so you see this is like the original stack trace that we had before. Here's the separator. And here's some new additional information that we're getting. We have this. Oh, it's F2, it's banana. And we even find the main function this way. So we get a much better stack trace that includes the trace of the previous thread. So that's kind of nice. So when I saw that, I was thinking, hey, why don't I just put this into an implicit class and use it all the time, right? Which is pretty much what I've done. You have this with trace method that comes from an implicit class. And I'll show you where you can get that later. It's on GitHub. But basically, any future that you have, you can just put a with trace on it and get like the additional stack trace. And just in case that this future func comes from some library, for example, or some code that you can't change, then obviously you can put it right here, right? It's the same thing, right? This is a future too. And any future, you can just put a with trace at the end and yeah, get the same thing. So let's take a look at like a slightly more complicated example. Let's say that we have two microservices, right? A and B. And A calls B, but from many different places in the code. And what B does is that it has one endpoint. It takes a string parameter. If it starts with the letter A, it'll throw an exception and return a status 500. Otherwise, it's fine. Okay, so I have this running on my machine, and some code that uses it. This is like service A, okay? So let's run this and see what happens. Good. Okay, so this is something that we used to have a lot in our code because, as Tom said, we have a lot of microservices around. So we would see something like this, okay? We're calling HTTP la 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 ABC. So we know that ABC is wrong because it starts with an A, right? And that's invalid. But we don't know how we got there, right? Because all we can see is this, which is our wrapper around calling service B, right? It's the service client. So this is all we know, right? And we don't know how we got to this state because we have this module that calls the client twice. We have this module which calls it, and they're all using like these complicated string operations. And we have this runner here that uses this hard-coded input, and it calls the modules several times. So, I mean, we can reason about the code. We can try to figure out what it actually does, but we don't know that from the stack trace, and especially if those strings come from user input, right? And you can also see that I'm printing out some thread IDs here. So we have 1, 15, 16. That's 3 different thread IDs. So you can see that this code is very asynchronous, right? It jumps around between many threads. So let's see if we can try to improve the situation here with a little with trace. So where should I start? So I started here in module 1 and module 2. I'm putting with trace after I call the other microservice. Okay, that's a good place to start, I think, because this is the future, right? So I put it here. So when I run this is already better because this is the original stack trace, and from here I can get to this line. Okay, so it's module 1 that's responsible, and it's particularly this line. Okay, so this is what's causing the exception, but module 1 gets called twice, right? On this line and on this line. And I don't have like the trace up to there, so maybe I should add it here, because these are futures as well, right? And the nice thing about this with trace extension is that, as I said, it concatenates the stack traces. So you can call it multiple times, and it will just add another stack trace and another one. So yeah, so here I added it here, right? And I also I added a with trace to the whole for comprehension, because that's another feature, right? That's another context switch. Okay, so this F is the result of the for comprehension, and here's a with trace around it. So when I run this should give me the best thing. So we start out here, where we throw the exception. Thread 1. Thread 2 is here. Yeah, we saw that. That's module 1. Thread 3 is here. Okay, that's the line. That's the invalid input. So if we do a drop 1 on this one, we get ABC, which was the invalid input. Okay. And thread 4 takes me all the way back to the main function. So this stack trace is much more useful than what we got before, because this actually lets me analyze what's wrong in the service, right? When I'm using like heavily asynchronous code and everything is a future, I do want to know when I have an exception, I want to be able to trace back and see like the actual line that caused it. Yeah, so cross-thread stack traces are very useful. I hope you share my opinion right now. All you have to do is add with trace to the end of your futures or for comprehensions. One thing that I didn't show in this demo is that it's very useful if you're using Akka, and especially the ask pattern. If you do, you've probably seen a lot of ask timeout exceptions all over the place. Some asks timed out, and then again you don't see like where it came from. All you see that like you only have like the stack trace for Akka's code, the ask code. So if you do this, you'll be able to trace back to your code and like the exact moment where you called this. So in terms of performance, it's important to remember that this with trace, it'll take the stack trace always, even if the future didn't fail, because it does that before you enter the future, okay? So if you're using it in some performance critical part of your code, you should probably test first. I haven't, so I think it's fast enough, but you should do your own testing and see for yourself. So if you can get this presentation, there's a link here. You can find it on Gist. Otherwise, just search for cross-thread trace. You should be able to find it on Gist. Thank you.